Welcome to our portfolio project, and then it's about AI sense on digital nodes. So today I'm Hazel, and this is Igor, my partner for this program, and then we're gonna share about what we did and then things like that. And then we have our mentor is Paul and also Tristan. So this is a picture of us and our sensor, which I'm holding in our hand, and then at the end we will have a live demo. So do you guys all know that we all humans have 5 senses? We have eyesight, we have smell, nose, we have mouth to taste, hearing, and then touch. So on AI, there's a lot of project that is being done on, let's say, sound. For example, you can relate to Alexa or Echo. And then there's a lot of project doing on the site, for example, computer vision, for example, autonomous car, for example, on the text, NLP, things like that. So, and then on the touch, you may see a lot of robotics things going on the AI project. So there's not that many projects that is being done on smell. And then you may wonder, can AI smell? And the answer is yes. So we're gonna go through our project step by step. So, so there's 7 little section of it. And the first one is introduction, which I just made. And then we're gonna share about the possible use case, the hardware, the data collection, predictive modeling, lesson learned, and deployment. So first of all, it's a supervised learning, and then it's also a classification problem. And then, so the following tasks we have accomplished in the last 1 month, for example, data collection. We collect a lot of sample, a lot of data in different conditions. For example, in room temperature, in outside where it is super cold at 2 degrees outside. And then we also put it into a, like in a bathroom where the humidity level is very high, and then check to see if the same food give out the same answer. And then you guys will see it in a minute. And then afterward, we do analysis, transformation, and then we have, at the beginning, we have collect data for 30 classes. And then later on, we decide to truncate it and then try to condense it and then focus on 13 classes to be predicted. And then later on, we have a lot of trial and error, and then we try to pick out the most suitable machine learning model. And then we train it, experiment it, and then later on, it's for the final prototype. So you may ask, what is this for, right? So so AI, there's unlimited possibility. So I'm gonna share top 5 that I choose for. And then actually everything that you can think of could use this device for. So I'm just putting some of the major one. So the first one is anosmia. So it means loss of smell. Do you know that it actually affects 2% of population because they loss of smell? And then actually 2% is an understatement. If you look at COVID number 1 symptom of those people is loss of smell and taste. Some people lost it permanently, some people lost it temporarily for a couple months. So this device is actually born in a good timing to be able to detect the smell for the food, for something that people really want to taste and then don't know what that is, and things like that. And then second is smart kitchen. Let's say if you have an oven, let's say if you have a chicken, you know that different manufacturer of oven, it may take like 40 minutes for a chicken to be done. And then it could also take 1 hour and 10 minutes. So instead of like keep going to the oven back and forth and then checking whether your chicken is ready or not, if you have a sensor that is built into your kitchen device, then it will tell whether the chicken is cooked or not, and then turn off the oven automatically by itself, for example. And then the next one is health check. So let's say if you have a watch with a gas sensor that is built in, and then every morning when you woke up, you kind of blow your breath in it, and then the indication can show you whether your diabetes level is low, high, and then or whether your oxygen level is good or not. So it's a pre-detection of any like serious disease that could be coming up in the future. And then the next one is my favorite one. So the next one is best coffee. let's say if you go to Starbucks and then you order a coffee, and then you know that like different barista, if someone is a student and then working for a Starbucks in the first day compared to someone who is working for Starbucks for 10 years already, the quality of the same cup of cappuccino could highly vary. So instead of hopefully you get a really experienced barista from Starbucks. If you have this machine that can control the quality of the coffee, that will make a huge difference. And then that will also give customer a promising result of, okay, I'm sure that I'll get the best coffee, the best cappuccino, stuff like that. Last but not least, if you have one of these sensors in your fridge, and then have you ever have chance that you bought some milk or egg into your fridge, and then later you find out that it's been bad after you drank it, and then you have stomach ache. So this will help you, save you some time going to toilet. And then, yeah.
Thank you, Hazel. Coming to the hardware part, how we have realized this project. Obviously, for this we took different pieces of different hardware, and first and the most main piece is visible on the top left image is the gas sensor itself. If you wonder how big it is just like this size. So compared to the microphone, it's just really small. We also used for the measurements on the bottom right image is a temperature and humidity sensor, so that the measurements are combined. For the reading, we used two options, wire terminal and Arduino Uno, which helped us to just read the data from the sensor into computer. So coming to the question how the sensor is working, what it is basically reading. You may have seen there are like four parts, like four small squares. And basically, these are the four heads of the sensor, and means that this is the multi-channel sensor, and it measures four different types of gases. It is carbon monoxide, nitrogen dioxide, alcohol, C2H5OH, and volatile organic components. Also, the second sensor is also reading the temperature and humidity for recording the environment. And to this point, we will come a little later. For the data acquisition with these sensors, we basically took different pieces of objects, mainly food, only food. And you may see on the images, especially on the right bottom images. So we put the samples into a glass and cover it with a piece of paper. And it's also here, and we will show it later. No, we will show it also later at the live demo, how it looks like. And yeah, basically we just let the sensor smell something.
All right. So at the throughout the project, we try to have a balanced data. So we try to have the same amount of sample of each classes after we decide to have 13 classes. So we try to keep the same amount of sample. That's why you can see on the pie chart that every category of food have almost equal share of percentage overall. And then this is one of the things that I mentioned earlier. So for example, coffee, you see 3 charts are here. So they are being detected on 3 different conditions. So the one on the right-hand side is the room temperature, which is about 25 degrees. And the one in the middle is outside. For now in Berlin, it's around like 2 degrees outside. And then the next one is a very humid room. For example, a room with that had just taken a shower, or a room with a humidifier. So as you can see on the x-axis is the time, and then on the y-axis is the value of those 4 elements. And then you can see that they are similar in some way, and they are also different in some way. That actually the graph changed some of the factor has been changed according to different temperature and humidity. Okay. So you look at the presentation and you wonder what are all these numbers about 6, 13, 120, 10, 1,200, 15,600, or 98%. So those are our secret sauce for the project. And I'm going to share one by one with you. So we have 6 features. As described by Igor earlier, we have 4 element that is detected from the sensor, which is the CO, NO2, alcohol, and the volatile compounds. And the last 2 elements is the temperature and humidity. 13. So we have 13 classes of food, and then 1/22. So the measurement is 1/22 for each of the sample, and then 10 is the hertz. It measures how often per second data is read. And the next one is 120 times 10 is 1,200. So we have 1,200 observation per classes. And the 15,600 is the total observation. So 1,200 times 13 classes. The next one is we have 4-layer or fully connected neural network. And then for that 13 class, we were able to accomplish 98% of accuracy. And then we were using different machine learning models, for example, features, TensorFlow, Keras, and sklearn.
So also on this diagram is basically the general representation of our work. We have collected the samples from the data. We basically send it to machine learning model, and afterwards we've got a prediction, and one of the outputs of the prediction you may see on the right part of the slide is basically we get probabilities of the detected objects. Thank you. So now coming to the lessons which we learned during this project. Basically, the software in this case is not a problem at all. Means building model, even just usual shallow neural network does a really good job. The data should be just balanced, and no special treatment of data should be done because this is our data. We collect it, we decide which format, and so on. But the challenge is coming from hardware side, which was expected little, but was not expected so many challenges. So first of all, so this is the sensor itself. It was quite important to understand how it is working, what is the physics behind. And I will not come to this point right now because it's a lot. I may discuss about this long time and so on. But the first challenge is like this: all sensors must be preheated at least 24 hours in advance, and if it is new, even 72 hours. And on the bottom plot, you may see the time, which is basically integrated time of the sensor, and the scale is like the last point is 140 hours. And only at this point of like 140 hours of operation of a sensor, the data might be considered as a more or less stable and reliable, not before. Also, every time you turn it off, you should preheat it 24 hours. Surprise. Afterwards, the sensors are not identical to each other. This we did not expect as well. On the right side, on the right two plots, you may see the basically raw readings, raw data from the two sensors, which I placed at the same glass with the same object. At the same time, I collected, there is like microsecond to microsecond data synchronized, and the readings are completely different. Also, the readings are heavily dependent on the environment. Means if temperature changes of environment or humidity, then the readings also change. And that's why actually we added the temperature and humidity sensor additionally to this gas sensor. And it helped us to improve the data a little. Also, acquisition cannot be done instantly. So at least, according to our experience, at least like 5 to 7 minutes, the measurements, so the sensor should be located in a constant environment. So it means that's why we use here the paper cover, so that no air flows inside, no temperature changes inside, and only afterwards data might be considered reliable. And now the interesting part, like how we deploy the model. So basically it is working, and for like nice representation of it, we decided to use also a Streamlit package, which simply creates a nice web interface for which is user-friendly. And now we are coming to live demo, and we are going to show simplified model. Due to all of these reasons which I mentioned before, we have model only with 3 classes, just because it is working. I mean, it is working in different conditions and reliable.
So just to mention about the PowerPoint from Igor's last slide, we actually bought 2 different two identical sensor, but two sensor from the same company. And then it turns out that we measured the same thing, and then we could have completely different result, which is totally got us in surprise. So it's very sensitive pieces, and then there could be some little changes inside of each sensor. So
okay, well, now coming to the live demo. Right in this glass, I have coffee right now, and the sensor is already placed starting from the beginning of the presentation. And the sensor is connected to Arduino, as you may see here, and also on the bottom there is a temperature sensor, which is basically connected. Yeah. Now Hazel, press please reading data. And it is working. You may see the LED is blinking, and means the data is acquired. Yeah, well, let's see. Yeah, and the prediction, it is coffee.
So just to tell you guys that we're not cheating, as coffee powder inside a cup. So,
So we may have some beer, which stays. Beer. It may detect beer, and I hope it will be faster this beer because it is beer. This sensor also likes beer.
And then when it's testing, I'm going to explain a little bit on the chart. So the one on the left-hand side is the probability. And then for simplification, that's why we only have 3 classes for today's demo, because we have those 3 samples sitting in front of us. And then on the left-hand side is the probability, which shows which one is the winner for the smell. And then on the right-hand side is the chart of those 6 elements that we mentioned earlier. So the x-axis is the time from about 10 seconds. And then the vertical, the y-axis is the value, the index of those 6 elements on the right-hand side that you see. And then
well, right now I have placed the sensor inside, and as I told you, according to our experiments, it should be inside at least 5 minutes. But let's try, and you will see that slowly it will be like if we. So I don't know how much time that passed, like 1 or 2 minutes. Let's collect this data and try to predict, and you will see that it might be not correct at the beginning, which is predicted by us. Let's have a look. It is beer. Okay. I tell you, it likes beer.
Wow, this is unexpected, because normally, usually live demo is not working perfectly. And then second is because it takes like 5 minutes for the sensor picking up the smell from it.
We have one more sample.
So we prepare 3 sample, coffee, beer, and orange. So we're gonna try the last one to see if it works or not.
Orange. This looks like orange. And
zoom it.
Yes, okay.
So we have orange in a cup, and then we just put it maybe a minute ago, and then let's see if it works.
But it might need up to 5 minutes.
What?
Better than expected.
Yeah. Wow. Surprise. Yeah. So, thank you very much.
Yeah, we would like to say many thanks to all team of Data Science Retreat, to all teachers who explained us a lot, nice topics, and answered to all of our questions, sometimes too nerdy questions. Many thanks to Jose, to Paul, our mentor, to Tristan, to all of the teams, all of you guys. We really appreciated this time, and it was a really nice team. Thank you.